Assalamu alaikum and hello everyone. Welcome to Mathematics with Shahab Yaqub. So now in this particular video, I'll be solving a paper that is Pure Maths P1. This is of May-June 2025 and this is the third variant. So now let me add a page over here which will be about the analysis of this paper. So I'll be writing the question numbers over here and the time taken for each. Or maybe let me do like 3 questions first, 1, 2, 3, and then the total time taken for each, so that would be more practical and pragmatic. And then we would see what else could we decipher from it. So now let's look at question number 1. Question number 1, it says a curve has this equation. Let me highlight it. A curve has this equation such and such. Find the equation of tangent to the curve at this point. Give your answer in the form y is equals to mx plus c. So now this is about differentiation and it's about basic coordinate geometry. So let's get started with this idea. So let me remove this thing. First of all, show the differentiation. When you show the differentiation, y is becoming dy by dx, 2x becoming 2, and this after differentiation becomes this. Make sure to simplify it first. Once you simplify, then you plug in the value x is equals to 2. Again, you find the value of dy by dx, that is 5. Now we know that dy by dx is gradient of tangent. So if I use t, that is for tangent, but since you people are used to it, that's why I'm assuming it. Do not assume in the exam. You can use symbol t for tangent, m for normal, but first let the examiner know about it. So make sure that you take examiner in full confidence. So let the examiner know about it. Keep that in mind. So something important that I just explained over here. Let me put a box around it. No, not this box, the other box. And let's move on. So now gradient of tangent is 5. The point is there. Make a habit of writing it where it belongs. And then apply equation of a line. I personally prefer this one. Yes, the final answer can always be converted to this. So this is called the point slope format. And that is what I personally like. And then you get this answer. So that was straightforward. And by the way, we started like 2 minutes ago. So let me write down the time. This is, we started at 9:09 a.m. And let's see how much time does it take. So question number 1 is done. Question number 2. Now this is about geometric progression and trigonometry. The terms are in terms of sine. And what else can we do? We will say that the angle is such that theta lies between 0 and pi by 6. So now it says, given that the sum to infinity of the progression, so this is about sum to infinity is half, find the value of theta, give your answer in the form sine inverse k, where k is a rational number. Now, first of all, when we use the term rational, that means it can be written as a fraction based upon 2 integers, where a and b are integers. So that is rational. And the word irrational, if we use in mathematical terms. So if I use irrational, that cannot be expressed in this form. For example, square root 2, square root 3, square root 5, pi, e, that we will use in P3. So these are irrational. So now over here, this is the first term. Realize this. Realize that the first term, the T1, is this thing. And this is AR over here. Therefore, I can use the concept that R is T2 over T1. This is T1, this is T2. I'll find the value of R. I'll equate it to this by using the sum to infinity formula. That is A over 1 minus R. I'll find the value of theta. So let's move on. Now, first of all, if I say GP, So r is this much. That comes out to be 2 sine theta. And make a habit of writing the things down. A is how much? 4 sine square theta. Common ratio is 2 sine theta. First write it down, then proceed. So it should be this way. So now sum to infinity is half. We simplify, we solve this equation, and over here we have to use the quadratic formula. When we use the quadratic formula, show all the working. This is in terms of sine as opposed to x. So therefore the subject should be sine, not theta only, sine theta. Show all the working, write down what is A, what is B, what is C. And then I have a habit, it's not necessary that you do it. I evaluate b square minus 4ac first. So that over here, I can plug in this value. There is either an or. So sine theta is negative, sine theta is positive. Since theta lies between 0 and pi by 6, we know that sine is positive in first and second quadrant. And when we are talking about theta lying between 0 and pi by 6, we are only talking about the first quadrant. So therefore, we have to use this value. So now these are the nitty gritty details that the examiner takes care of it. And that's what distinguishes between an A versus an A star. Or maybe for that matter, between a B versus an A. So these kind of things you have to look for. What if someone chooses this thing or chooses both? Then they would be losing marks on this. So theta is sine inverse of 1/4, and we have to leave the answer in this form. We don't have to use the calculator. Sine inverse k, where k is a rational number. What is that rational number? 1/4. You don't have to specifically spell it out because the examiner is not saying so, but still you have to write it in this form. That is a must. So 2 questions are done. Let's move to the third one. It says, given that this expression equals to 12, find the value of constant A, 4 marks. So the limits are 1 and 3. This is about integration, basic integration, integration using chain rule. You have to take it up, do the necessary thing, and then plug in the limits, equal it to 12 and solve. So let's look at it one by one. First of all, you have to write it down like this. So I'm not writing down 12 at the moment. What I am doing is that I am just writing down this thing, the left hand side. And then let's look at it. Increase the power by 1, divide by the new power, increase the power by 1. Let me highlight it. So that is over here. Increase the power by 1, divide by the new power. Don't forget to divide by coefficient of x. And I'm not putting in c because I have to plug in the limits. So now then I plugged in the limits. You should, I think, plug in the limits from here. That's 1 and 3. And then what I did is that I first did the simplification. First simplify, then plug in the limits, then proceed. So I first simplified, then I proceeded it. And then what do I have? So it's the same thing. And what is the place where you will be plugging in the values? So you will be plugging in the value in place of x, in place of x. So that is in place of x, in place of x, in place of x, and in place of x. You plug in the upper limit first. So that is the upper limit. 3 goes here, 3 goes here. Lower limit 1 goes here, goes here. And then it's all basic arithmetic. You find the value of a as a beautiful integer. That is 36. So now this is 917. 3 questions are done. Let me move to this one. So 909 till 917. So that's how first 3 questions are done. So let me write over here. Question number 4, question number 5, question number 6, and I'm starting, let's say I'm taking a small break, let's say. So let me start at 9:18 a.m. and then proceed, and let me shift this page all the way over here. So now we can have a good look at it. So now question number 4, we are starting. This is binomial. Find the first 3 terms in the expansion. Nothing is unknown. It's just basic usage of formula. So we will write it like this. That is 5c0 This is b raised to power of 0, a raised to power of n. That's the way that I use. 5c1, b raised to power of 1, 2 raised to power of 4, 5c2, b raised to power of 2, 2 raised to power of 3. Take care of the negative sign when it's raised to an even power versus when it's raised to an odd power. So now this is some of the values are too easy. 5c0 is 1, and over here, let me just write it for a second. So 5c0 is 1, this is 1, 2 raised to power 5 is this thing, 5c1 is 5, 5c2 is 10, and then you work it out. So you get this thing. And then when you proceed, use your answer to part 2. So now this was kind of new in the sense that they asked us like an out-of-box question. Use your answer to part A. Naturally, they are giving us the hint with a suitable value of x to find an approximation for this thing. So now this is the answer of part A. The expression that we are using. There is a power 5. There is a power 5. There is all this thing written over here. There is this thing written over here. So what is the suitable value of x that we will plug in? That we will get it with comparing coefficient. So now 2 minus 3 over 2x is 1.985. Use a calculator. We find the value x is 0.01. That means using this binomial expansion, I can find the approximation of this, because the expansion of this, you are now substituting this value. You want to find the approximation for this, but using a substitution of x is 0.01. Now plug x is equals to 0.01 in the expansion, you plug it in, you get this answer, and of course you can check with your calculator. So because they want us to use this, they are not just asking 1.985 raised to power of 5, that answer is almost as close as this. I think it is 30.817 or 819, something like that. So of course this is all got all clear. You have checked it before even the examiner starts checking. Now let me look at question number 5, trigonometry. 4 sine theta tan theta is 1 plus 5 cos theta. Look at this. Theta lies between 0 and minus 180 and 180 degrees. So now when we have this thing between negative 180 and positive 180, what it means is that from 0 till 360, from 0 till 180, my bad, from 0 till 180 degrees, you are going anti-clockwise. Anti-clockwise angles are positive. So this is 0 till 180. This is the first quadrant, this is the second quadrant, that's the normal thing. And when you are going in this direction, 0 till negative 180, 0 till negative 180 degrees, you are going clockwise. And we know that clockwise angles are negative, whereas anti-clockwise angles are positive. So this is positive angles are anti-clockwise. So now we will use a small grid and just take care of that for these two quadrants. And by the way, these two quadrants are which one? That is fourth and third. I'm saying fourth first because we are starting with respect to x-axis. So now that was the special thing about it. Let's see. First thing first, tangent is written, let me grab a highlighter, there it is. Tangent is written as sine over cos. That is the change that's taken. Cross multiply, we get cos theta plus 5 cos square theta. And what's the next thing? The next thing is this thing. This sine square theta, we are changing it as 1 minus cos square theta. And then what are we getting? We are getting this quadratic equation. I use the quadratic formula, not in a mood to take any risk. I find two values of cos. The first one is cos equals to this thing. So let me highlight this. Cosine equals to negative of this. And then over here, we are getting cosine. Let me use orange one. So cosine equals to positive of this. So now there are two options for positive, first and fourth quadrant. Calculate the basic angle. Let beta be the basic angle. For negative, second and third quadrant, basic angle is always taken as positive. With a positive ratio, you get this thing. So now over here, what I'm doing is that for the first quadrant, this is all good. And for the second quadrant, this is all good. And let me draw a small diagram. So I need a little bit of space. And let me write over here this thing. So again, let me draw a grid over here. Let me draw a grid over here. Let me draw this angle in the first quadrant, that is like this. Angle in the second quadrant, that is like this. So first of all, let me use a green thing. This angle is this one, 52.16 degrees. So let me focus on this. This is 52.16 degrees. And when we are talking about the same basic angle downstairs, that means below the x-axis. So let me use this thing, and it would be the same thing downstairs like this. So this is negative 52.16 degrees. This is first quadrant, this is fourth quadrant. So this is first and fourth taken care of in the same manner, like with this basic angle, 52.16 degrees. I hope you got this thing. And similarly over here, this one is this one. This is 180 minus 43. This is 136.43 degrees. This is 136.43 degrees. That is in the third quadrant. And let me grab another color. Let's say a greenish color like this. And in the fourth quadrant, sorry, in the third quadrant, the above one was the second. So let me just correct myself. That is the second quadrant. So therefore, we'd be going like this clockwise, reflection of that angle. So that is negative 136.43 degrees. Also, the clockwise angle in fourth quadrant is a reflection of anti-clockwise angle in first quadrant. Got the idea? Similarly, the clockwise angle in third quadrant is a reflection of what? It's a reflection of anti-clockwise angle in second quadrant. Keep that in mind. So now this one gets reflected over here. This one gets reflected over here, and we will use this knowledge in P3 also. So now question number 5 is all done. Let's move to question number 6. Another progression question. This time it is arithmetic. Now it says an arithmetic progression has the first term a, common difference 2. The nth term is 55. Sum of the first three n terms is 5760. Find the value of n and a. So now first of all, look at this Tn, the term formula. So we have the term formula, Tn is a plus n minus 1 into d. Let me choose a lighter color. That is Tn formula. And the Sn formula, that is over here, that is Sn equals to this thing. So now over here, when they are talking about the nth term, so instead of small n, I wrote a capital N. A is unknown, capital N is unknown. That is equation number 1. Sum of 3n, so instead of n, it's 3n that has this value, and instead of n, I'm writing 3n over here. So let me focus on the important details over here. Let me just change the color. Hold for a second. Okay. So now this n is this 3n, that is plugged in over here because of this. And let me use an eraser. Okay. And over here. So now this 3n is taken care of it. And over here, this pink n, that is this one, that is taking care of this. So that is how the two equations are formed. So now this is equation number 1. This is equation number 2. You solve it simultaneously, but it's done in a very nice manner. That is, what I did is that, a little bit out of the blue, a little bit cheeky, that is 2a plus 6n minus 2. Focus on this. What I did is that I took this thing and I broke it up. So I broke up 6n into 4n over here, 2n over here. Got it? This is still 6n, but 2a plus 4n is 57. So that is what I have substituted. So now that's kind of cheeky. And then I simplified this thing. I get a quadratic equation. And the values of n are coming out to be positive 24 and negative. N has to be a positive integer because n is the number of the terms. So let me write integer in a nice way. It has to be a positive integer. So that thing is all done and dusted, and the value of A is 9. So now question number, this thing is also done. That is question 6. It's 9:28. So let me first go ahead, grab this thing. Let me put it over here. So 9:18 till 9:28, that is 10 minutes. Now keep in mind, this 10 minutes is for narration. The question was already solved. So for you people, let me double it, because you don't have to do the narration. So for you people, it should be 20 minutes for students, 20 minutes for my viewers. 9:09 till 9:17, that is like 8 minutes. So 8 minutes of SY work should translate into, with all the narration, like 16 minutes of student work. So now this is the analysis so far, and it's a pretty straightforward paper till now, nothing very special or something like that. So 4, 5, 6 is done, question number, and then the time duration, let me make it like this, the time duration by SY, the time duration for you people. So now hold for a second, let me write 7 and 8. We'll first analyze these two, then 9 and 10, and then we will analyze 11 if there is 12. I don't think so there is 12, there must be an 11 also. So now question number 7 and 8, and let me just take care of it. So I think it's gonna go this way like this. So now this is question number 7. It says a curve is such, and this is 9:30, and you can take some short 1 or 2 minute breaks in the middle, no harm about it. A curve is such, dy by dx is this. Find the set of values of x for which y decreases as x increases. That means this is the phrase that defines a decreasing function. That means derivative is less than 0. So now you already have dy by dx, make it lesser than 0, middle term factorization, and then what is necessary for solving a quadratic inequality. So remember, for quadratic inequality, drawing a sketch is a must. The coefficient of x square is positive, that's the shape. The roots are positive 2/3 and negative 4. We are talking about the region that is below the x-axis. This is below the x-axis. So that is this region, and this region is possible between these two values. So one single region, one single inequality, that is the answer for 3 marks. Second part, it is given that the maximum point of the curve has y coordinate 27. Now there are 2 turning points. This was used for inequality. In reality, if I made dy by dx is equals to 0, so these are the 2 turning points. So I already have the factorize, and let me write down the turning points over here. So the 2 turning points are x is negative 4, and the other one is x is equals to positive 2/3. Now we don't know which one is giving a maximum, which one is not. So now let me check by plugging in x is equals to negative 4, and coincidentally it's giving me a negative, so that's a maximum point. Now someone can ask this question, what if we plugged in 2/3? Of course it will give you a positive value, that will be a minimum. Naturally that will mean that x is equals to negative 4 has to be a maximum. We integrate this thing term by term, constant of integration, simplify it, plug in x is negative 4, y is 27. X is negative 4, y is 27, find c. We find the value of c as 21, and then you write the equation of the curve. So I think that was pretty straightforward. Question 7 is done and dusted. Question number 8. Now question number 8, it says the diagram shows a square where each side has length 12 centimeter. So it's a square 12 by 12. Points E and F lie on the sides respectively such that BE is 1/3 BC. So BE, where is BE? That's BE is 1/3 of the whole thing. So if this is 12, 1/3 of 12 is 4. The same goes for this. DF is 1/3 of DC. Now the arc EF is part of the circle. Now if I focus on the circle, so what do we have? We have this as the radius. We have this as the radius, and this is the arc length that is produced because of these two radii. So now that thing is done, and then it says the shaded region is bounded by such and such, that is given. First of all, they are asking us, show that the size of the angle EAF, that is this angle over here, the size of the angle EAF is this much, correct to 4SF. That means, remember one thing, work in this question, work in 5SF at least. So at least includes 5SF, so I think I'll just work in 5SF. Now over here, a little bit basic trigonometry is needed. It's a square, so 90 degrees are there. I can find this angle beta, I can find this angle beta. So beta plus theta plus beta is equal to 90. 90 in radians is pi by 2 radians. The value of pi that I'll use is 3.142, correct to 4SF. Actually, I should have used 5SF, but I think it would work. Or I can use the calculator value. So now, let's look at this. Tangent of beta is 4 over 12. You find the value of beta, 5SF. Beta plus theta is this much. So I should have used it, but I just worked out with this, and it's giving the correct answer, 4SF. Find the perimeter of the shaded region. So now the perimeter of the shaded region should be FC, which is 8, EC, which is 8, plus this arc length based upon this, and this is the radius. In order to find this radius, use Pythagoras theorem based upon this right angle triangle. So now, first of all, AF square is 4 square plus 12 square, that is root 160, that is the radius of the sector. Arc length, radius into theta, use the 4SF value, that is 11.73. Perimeter is arc length plus that 8 and 8, and you get this answer. Now for this part, they were saying give the answer correct to 4 significant figures. For the other parts, they are not mentioning anything. That means the rubric of this exam paper says non-exact answers should be worked in 3SF final. So therefore, I'm working in 3SF final and 4SF before that. Find the area of the shaded region. That means from this square, subtract this triangle, which is the same as this triangle, and this is the sector. If I subtract two triangles in one sector, I'll find the area of the shaded region. So now, area of triangle, half into base into height, 24. Area of the other triangle, 24. Area of square, 12 into 12. Area of sector, half r square theta. I'm using the exact value to preserve accuracy. So square minus triangle minus sector is giving me this. Rounded off, you get this answer. So now our two questions are done, 7 and 8. We started at 9:30. So we started at 9:30, and again I'm mixing these two up, and this is 9:36. I think that was too fast. So SY time is 6 minutes. For you people, this should be around like 15 minutes. And let me also increase this time. So 16 minutes, let me make it 20 minutes for you. 20 minutes, let me make it 25 minutes for you. Okay? So now the analysis is this, that question number 1, 2, 3, that is like 20 minutes for you people. Question number 4, 5, 6, that is 25 minutes. Question number 7 and 8, that is 15 minutes. And then we would add to it 9 and 10, and then we would add to it 11, and then we will total, because the time limit that is given to you is 1 hour 50 minutes, 60 plus 50, that is 110 minutes. And let's see how much time will be left. This is your working. This is not my working, this is your working time with all the relaxation, all the tension and everything associated with it. So now let me take this thing all the way over here. Okay, and let's get started with this. Again, note down the time, that is 9:37. Okay, so question number 9, that is a circle question. And the question says 3 points, PQR have coordinates such and such, where K is a constant. It is given that the angle PRQ is right angle. Show that one of the possible values of K is 10. Find the other possible value. So it's a good thing that the examiner helps you out. So now I have done it using gradient. Someone can do it using what you call Pythagoras theorem also. So now what I did is this thing. Let me write over here. This is P, this is R, this is gradient, and the simplified gradient over here. Over here, this is Q, this is R, this is gradient, this is simplified gradient. When we are talking about PRQ, so therefore angle R we are focusing on. There is P over here, there is Q over here. That means I need this gradient PR, that is right over here. I need this gradient. Let me just change the color. So there is no confusion. This is PRQ. I need this gradient, which is PR. That's right over here. I need the gradient QR, which is right over here. Now, if they are perpendicular, it's a 90-degree angle, perpendicular. So the gradient should multiply to give you -1. And we calculate, do all this working, quadratic. Quadratic is always there. And we are getting two values, K is -4 and K is +10. So -4, +10, that is how this is done and dusted. 9 part B, it is now given that K is 10. So now they have given us the value of K is 10. So 2 comma K actually becomes 2 comma 10. A circle passes through the point P, Q and R. Now keep in mind that for this value, it's a right angle triangle. Okay. So find the equation of tangent to the circle at R. Give your answer in this form where A, B and C are integers. Now first thing first is that PRQ is 90. So the side, excuse me, the side opposite to R is PQ. Ignore R, you're left with PQ, that is the hypotenuse. And that hypotenuse has to be the diameter of the circle. That is the diameter of the circle. That is the property that we use. Let me just draw a small circle over here somewhere. And let me draw a hypotenuse, just like a diagram or something, a rough diagram. And hold for a second, like this. And then I can draw one line like this. I can draw one line like this. That is the scenario over here. So that scenario is, this is R, this is P, this is Q, this is 90. Find the midpoint of P and Q. That would be the center of the circle. So M would be the center, MP or MQ, that would be the radius of the circle if it's needed. And they want what? They want equation of a tangent. So equation of a tangent, that can be drawn like this. You can find the gradient, negative reciprocal kind of thing, and then you find the equation of the tangent. All good? So radius in this case will not be needed. So now over here, let me focus on this. That is midpoint M of P and Q. That is the center of the circle. That is 4 and negative 4 and 3. Now we have C, we have R. We find the gradient of CR, that is 7/6. Therefore, gradient of perpendicular. So radius is perpendicular to tangent at point of contact. So now you find this thing, negative reciprocal. You have this thing, and then you find the equation of tangent, which is now given in this form. That is ax plus by plus constant equals to 0. Now, what if someone takes all the things to the other side? That is also acceptable. So that is what the examiner has written. All good, all clear? So now 2 questions are done, and this is question, no, my bad. That is, I think, 1 done. Question that we did, yes, 9 is done. Of course, the time would be taken more because the number of marks are increasing. So now let's look at question number 10. And question number 10 was a very nice question, I would say. First of all, it says a curve C has this equation. Find the coordinates of the 2 stationary points. That is basic. You differentiate, apply the chain rule, take the power down. Let me just highlight it. So take the power down. Power reduces by 1. Don't forget to multiply by derivative of bracket. And then simplify. And then you are getting this. So now, once you get this, what is happening? They are looking for the stationary points. So therefore, dy by dx equals to 0. And I forgot to write this when I'm in a hurry. So 2x minus 5, 2x minus 5, 2x minus 5. You simplify. You can see the working. take the square root of both sides, and what do you get? You get x is equals to 1. Let me highlight it. So therefore x equals to 1 and x equals to 4. So these are the two answers. X is equals to 1, x is equals to 4. And then let me just show you. This is find y coordinates. Don't forget the y coordinates. So the space was a little messed up. So sometimes, yes, I do realize that the space is a bit messed up. So make sure that you have everything on the left hand side like this. And then let me just show it to you right now. That is this thing. That over here, let me just push this thing all the way to the left. That's one thing. Then let me push this thing up till here to the left. Okay. Now this thing is done. Let me push these two sidewards. Let me write it like this. That's how it should be organized. Let me remove these arrows. And again, let me grab this thing. Let me write it over here. Let me write this thing over here. Now let me write over here either or. So this is either, this is or, and then let me write x is 1 and x is 4. So now I could have saved some space like this. So now this is all good, all clear. Now this thing makes sense. Find y coordinate. So now y coordinate is like this. And then don't forget to write the coordinates. The coordinates are over here. That is 1 and -6. And the other one is 4, 6. These are the two coordinates that we are getting. So all good, all clear. So now this is all neat and clean as compared to before. Now find the second derivative and determine the nature. So you again differentiate. Of course, you would use this particular simplified format with indices. You differentiate, you simplify, you plug in x is equals to 1. So now let me use two colors. One is the blue color, that is x is equals to 1, x is equals to 1. It's giving me a negative, so therefore it's a maximum. And the other one, that is 4, it's giving me a positive, therefore it's a minimum. So far, this is differentiation. And then over here, this one was a very nice one, even though it's for 1 mark and maybe like 2-3 marks a hit. So this is transformation. It says over here, the curve C is transformed to curve C1. So the original curve is C. It is transformed to a curve C1 using a translation, a horizontal translation, a vertical translation, followed by a reflection in x-axis. So now, how do we show this? First of all, they are asking this thing based upon the maximum. They're asking this thing, and there is one hidden thing, that is, they're asking for the maximum. Should we only work with maximum or should we work with both? We should work with both. What is the reason? I'll just tell you. This is the maximum point of C. So when it's written -3, that means we'll be moving 3 units to the left and 7 units up. So this is blue, that is 3 units left. And the green one is 7 units up. So now what I'm doing is that I'm subtracting 3, I'm adding 7. We are getting these two things. And then this purple is for reflection in x-axis, only y coordinate changes sign. So let me write over here, only y coordinate changes sign. So now I'm getting this thing. When I apply the same to minimum point of curve C, I'm getting this thing. So now because of this minus, the maximum will become the minimum and the minimum will become the maximum. So technically the answer for this one is this. So this is the answer of 1 mark for part C. This is the part C answer. Why? Because the maximum of C is now the minimum of C1. The minimum of C is now the maximum of C1. So that is the logic, and that was asked only for 1 mark, so that very few people would be able to do it. They understand this, so that most people don't lose any marks. A very, very nice question. I would give it a 5-star for this thing. Now they are asking, find the equation of C1 in this form. Now, first of all, you have to show all the steps. So now we have blue, green, and red. So the blue working is for the X thing. So now when we are writing in terms of equation, we write a plus 3. We write a plus 3. Wherever there is X, X is written as X plus 3 because it has the opposite effect. And whenever we are writing the Y thing, that is only a plus 7. That is the normal thing. So that is the first thing that I did. So basically, I'm converting C. So this is curve C to let me convert into curve D before it gets converted to curve C1. So this is like an intermediate step. So there is curve C, there is curve D, there is curve C1. Once this is done, what I'm doing is that I'm multiplying with a negative sign. So let me write the transformations involved over here. One is this thing, fx plus h. It means h units to the left. That is one thing that was applied. Fx plus k, that is k units up. And then fx with a negative sign, that is reflection in x-axis. These are the three things that were applied over here. So now I did something extra. What I did is that I just used an app and I drew this thing. You can see the minimum, you can see the maximum. Sorry, this is the maximum, that is 1 in negative 6. So let me highlight this color. So this is the maximum, that is this one. And this is the minimum, that is this one. Now apply the translation. Now when I apply the translation, it should move 3 units to the left and 7 units up. So that is what we are getting. Now the maximum point is negative 2, 1. So 1 minus 6 is becoming minus 2, 1. Okay. And similarly 4, 6 is becoming 130. Now apply reflection in x-axis. That's the final graph. And it's exactly corresponds with what we have done. So this is some extra stuff that I have done. This is just for fun, just to give you an idea. But the reality was all done, all dusted over here. So now these two questions are done. And now the analysis, I think started at 9:37, I think. So we started at 9:37 and this is 9:51. How many minutes is that? That is, I think, 14 minutes. Therefore, for normal people, let me write this thing as 30 minutes. So therefore, this is 30 minutes over here. So far, let's see how many minutes have you used. So 20 plus 25, that is 45. 45 plus 15, that's 1 hour. 1 hour, 30 minutes. Not bad. 1 hour, 30 minutes. Still, we have 20 minutes left. And the last question is pretty simple. So that won't be an issue. So now this says the function f is defined by fx as such and such, gx is such and such. Look weird, but it's a very easy question. Given that the range of fx is this much, find the possible values of a. So now this is like an out-of-box question. You have to realize that when I draw a quadratic curve, so whatever is the k value, if I go to the right, the y value would be on the increase, or maybe if I go to the left, the y value would increase because the coefficient of x square is positive. So all I did was that to convert it into the completed square form so that I'm interested in the y coordinate of turning point. So that is the completed square form. This is the y coordinate of turning point. This is with respect to y coordinate of turning point. No inequalities were harmed in this solution. All you do is that take this, equate it to this, solve, and you get 2 values of a. That's it. But the thinking was out of the box. 4 marks right away. And over here, it is given instead that f of g, this is composite function, equals to 96. Find the value of a. I wrote fx, I wrote g inverse. First thing that I worked was that I need to find the expression for gy. my bad, gx. So let y as g inverse x, therefore gy is x. Replace with y, make x the subject, x as gy, and then write it in terms of x. Now what you need to do is that very simple, f of g0. That means first evaluate g of 0, that comes out to be 2. Then plug this 2 over here. So f of g0, we are going like this. G of 0, that is coming out to be 2. And then over here, g of 2, that is coming out to be 6. And then last but not the least, f of 6. So f of 6 is in terms of a. This answer is 96. I don't know why they have given 6 marks for that. Many marks over here, and that is how this is done. So let's say 1 hour 40 minutes. You can comfortably, the student SY can do this thing in 1 hour 10 minutes easily. So for normal people, 1 hour 30 minutes that you can do. Still you have 10 minutes left for relaxing. So now that's all from Mathematics with Shahab Yaqub. This was which paper? May, June 2025, variant 1-3. And yes, from this year, they now have 4 variants. So stay tuned for more content on Mathematics with Shahab Yaqub.